In this presentation, we will install Hadoop. Let's review the process. By now, you have completed your host preparation steps, and you are either using a virtual machine or you plan to install Hadoop directly on your Windows, Mac, or Linux host. This process will go fairly quickly. As soon as you unpack the Hadoop tar, you'll be able to do a test run of Hadoop using the local file system. Next, we'll configure Hadoop for pseudo-distributed mode. Finally, we will configure Yarn so that our MapReduce job will be containerized. This is exercising the full set of daemon processes required to run MapReduce on a cluster. This is as real as we can get with only one node available. Before we jump into the installation, we should verify that we have completed the host preparation steps. If all looks well, we are ready to download and run Hadoop. I will be using VirtualBox and the Ubuntu VM I showed you in the VM host preparation videos. One thing I noticed in testing the VM is that I needed to increase the RAM to 4 gigabytes. There were Hadoop stability issues with only 2 gigabytes. If you have more RAM, you could go higher for your VM. You may have noticed that I have a snapshot of my virtual machine. You can use snapshots to save the state of your VM before you make changes to it. You can then revert back to the snapshot at any time. So the virtual machine's booting, and now we can see the Ubuntu splash. I'll fast forward till we get to the desktop. Let's pull up a terminal and take a look at the environment variables. Recall that we placed them in /etc/profile.d/hadoop.sh. I'm using VI, but you don't have to learn it, as there are other text editors available in our Ubuntu installation. Wait, I see here that I forgot to use the export command, so we'll need to edit this file and then log out and log back in for this change to take effect. Okay, we'll open up our terminal again, and this time we'll check that our Java home is set properly, and it is. We also need to check that our Hadoop installation folder is set up. So we'll do an ls and show all the attributes. We can see that the folder is there and it's owned by our user, htadmin. Okay, so now let's open up a browser in our VM here in the Ubuntu desktop. We can use Firefox and navigate to the Hadoop homepage that's on Apache. That's hadoop.apache.org. Now I'll scroll down here to the Hadoop 3.2.0 release. If we go there, we can quickly click on the download the tar.gz file. I've already downloaded it, so I'm not going to do that now. But you should download it, and then I'll demonstrate how we unpack the tar. As you can see, I have it already in my downloads. So let's pull up the documentation. You can read through the release notes, but let's go right to the setup instructions. So we're going to be setting up a single node cluster. Now we've done a lot of the prerequisites, so we can focus on downloading Hadoop and unpacking the tarball. If you haven't downloaded it yet, you could use this link to take you to the mirrors for download. So let's go back to our terminal, navigate to our Hadoop directory, that's user local Hadoop, and let's unpack the tar. You'll see a lot of files being unpacked here. I'll fast forward till the end. So let's try to run it. And oh, we're not in the right place. Let's cd into the Hadoop 3.2 directory and try that again. And it ran and displayed the usage documentation for Hadoop. So let's continue reading our documentation. We're going to start with the local mode. standalone operation. And to do that, there's nothing you really have to do configuration-wise, but we are going to set up for a test, and we'll create a input directory right where we're sitting. And we'll copy the Hadoop config files, the XML files, into the input folder. And then we'll just run Hadoop, and we'll run this jar from the Hadoop examples. I'll have to get back over to the page to grab the rest of the command. And what this is doing is a grep through the configuration files, but it's doing it in using MapReduce. This is our first MapReduce job. Paste that, hit enter, and Hadoop is off and running. So you see a lot of output here. We're not going to worry too much about studying the output. At the end, there's a list of counts, and that the meaning of those things will become more clear as you use Hadoop. But let's take a look at the output folder. We've got only one keyword that got captured by the grep statement, and that's the name DFS admin. And you can see that our pattern is, it has to begin with DFS and then have any alpha characters or dots. So that's our local operation. But if we scroll back, we can see in our logs that we're using MapReduce local as well. So it's using the local file system, and we're running MapReduce in a local mode. Let's take a look at our directory structure here. We have the output folder that got created, and we have the input folder that we created, again, on our local file system. So let's set up for the next step, which is running in pseudo distributed mode. So we'll need to edit the Hadoop configuration files. We'll start with core site.xml. As you can see, the configuration is empty. So we're going to cut and paste the property over here. This first property is declaring that the default file system is now a service on localhost at port 9000. And that's where the HDFS daemon will be listening. The next file is HDFS site, and here we'll set a property to force the replication factor to 1. The default replication factor is 3, and with only one node, we can't really maintain 3 copies, so we have to set it to 1. So we'll finish editing, and then we already have this set up, but let's test it. Let's make sure we can SSH the local host. And we can, so we can log out. And we've generated our keys, so we don't have to go through that part. So we've got the configuration done. Let's get ready to run HDFS. So first thing we need to do, though, is format the name node and essentially initialize our distributed file system. So we'll run the format command. Everything ran fine. The next thing we do is start up our daemon for DFS. And we have some errors here. So Java home is not set. Let's grep through our Hadoop configuration files for Java home. I imagine it's in one of the .ssh files, and sure enough, okay. We want to edit hadoop-env.sh. Let's pull the file up. So it is required for that we set Java home in this file. So let's find where the export command. Oh, there it is. So uncomment it, and we'll add our path to Java. I think that's not user local, user libjvm latest. Okay, we'll close that and let's try it again. Much better. So it's starting, the name node started up, it's starting the data node, secondary name node. And we've got it up and running. So we're going to cut and paste this URL so we can look at our HDFS UI. And it's coming up. There's our HDFS. We've got a total of almost 20 gigabytes of storage, of which a lot's being used, so we only have 11 gigabytes available for HDFS. Let's go back to the instructions. Now we need to set up the file system to support users, so we'll create this user folder, and then we'll create one for our user. We can use the environment variable user. And then we're going to run the MapReduce job, so let's create an input folder. And then we're going to copy. We're going to use the put command to put our config files into the input folder. And what this will do is transfer files from our local file system over to HDFS. Now there was an error. I've seen this before. I don't think it's anything serious. Well, our services are still up. Let's see, name node, secondary name node, and a data node. That's all you need to have HDFS available. Let's take a look at the input folder, and it looks like the files are there, so we're going to ignore that error for now. If it crops up again, we'll have to address it. So now we can run our MapReduce job, the same one, using the same command that we did before. However, this time it's going to be reading from HDFS and writing the output to HDFS. It will look similar. And the job's finished. If we go back and look at the counters, we could see that we're reading and writing from HDFS. Let's get the output folder and put it in output. This doesn't look right. Let's see. Oh, we still had our original output folder, and I think we downloaded the one from HDFS and put it there. So let's remove our original output folder and do the get again. Now when we look at it, we'll see not just DFS admin, but dfs.replication. That's a change we made to the Hadoop configuration files. Now there's another way we could do this. We can cat directly from HDFS. So we'll use our HDFS DFS minus cat and just cat the output directly from HDFS, and we see the same thing. Okay, so let's stop our DFS daemons. That will stop the name node, stop the data node, and stop our secondary name node. And then we can move on to Yarn. So now with Yarn, we need to add additional configuration. We'll start with editing our MapRed site file. And this time we'll add a couple of properties. The way it is, it's depicted in our instructions here isn't correct. So you don't want two configuration sections. You only want one. So let's just copy each property individually and place it in our configuration. So we have the MapReduce framework name is now Yarn. So we're telling MapReduce we want to use Yarn. And then the second one is setting some class path names. We won't get into the details just now. So the next file we need to look at is Yarn site. And here we're going to just simply cut and paste the two properties. One is to define MapReduce shuffle as the aux service for Yarn. And then the second one is to put in a whitelist. Again, we don't have to understand this just yet. Well, let's check our memory. We have 4 gigs, that's the way I set it up. And there's about a little under a gig free. But that's buffer and cache, so we actually have 2 gigs available. So we're starting Yarn. It's starting a resource manager, a node manager, and that should do it. Okay, let's check with our JPS command, Java processes, and it'll list the resource manager and the node manager. We need to start up our distributed file system, so let's start those daemons. We have the name node, data node, and then the secondary name node. Let me cut and paste our URI for the resource manager. And we'll take a look at it. Now it's a pretty wide view. I'm only showing you part of it here. Let's go back to our instructions. So we are going to remove the output folder. And then we'll run the jar again. So this is a MapReduce job running with Yarn and HDFS. So you can see it's connecting to a resource manager. We have a URI for monitoring our job. It's going to take a little while to run. Let's see if we can pull up the job. I'll click on it here. I don't know that it'll open it up in Firefox. Let me cut and paste it. Things are a little sluggish because I've got this Yarn job running. So we pull up the application and we can see it's still running over there in the shell. The web service is coming up and we can see that our job's in progress. So if we go back to the shell, we were 67% through our mapping. And now we've finished the first job, and then a second job runs as part of this MapReduce. Now that first job is finished, so I don't have the history running. There's a history service you have to run. So we can't really see history, but we can go back to our show all applications so you can see the second one is now in the running state. And it's now finished. Again, if we click on the history, it won't take us anywhere because our history server is not running. We'll get that up running later. We'll do a little tuning on the cluster, but we've got it. We've got HDFS and Yarn, and we just ran a MapReduce job successfully. This is all you need to have working for your homework for this week. So if you've gotten this far, congratulations. You're going to need to take screenshots and answer a few questions in the homework. So now that we've gotten things running, let's shut it down. It's a good practice to shut down the services. We'll stop Yarn, and then we'll stop our DFS daemons. And then you want to close your virtual machine down as well. I don't recommend just leaving the services up and running and the VM up and running and then putting your laptop to sleep and bringing it back. You'll probably end up with a corrupted file system. You may end up with a corrupted file system anyway. This is not the most stable way to run Hadoop, but it works good enough for the class. All right, so we've shut down all the Java processes. When we run JPS, we don't see any. Okay, so we've completed our single node cluster setup. We downloaded Hadoop 3.2. We expanded the tar file and we followed the documentation for the single node cluster setup. And for the most part, the documentation was right on. We did learn a couple of things. One, I didn't have to configure Hadoop Home. I think that's been deprecated with Hadoop 3. But we did have to put Java Home in the Hadoop environment shell script. So we learned that. So I hope you enjoyed setting up your Hadoop development environment. There's still more to do. We'll have to do some tuning, and we'll have to set up a programming environment with an IDE. So more to come.